Hello, and welcome back to the Product Academy. My name is Javier Roldán. I am experimentation lead at Adevinta Spain, and also I am the content owner of the experimentation module in the Product Academy. As an experimentation lead, my goal is to help teams do good experiments in order to develop our products in the best possible way. We have seen in lesson 8 with Anastasia how to define a good metrics when running an A/B testing. In this lesson, we are going to learn about sample. What is, again, in this lesson, we are going to learn about sample. What is and how important is the size and representativeness when defining your sample. Before starting with the lesson about sample, let's do a little summary of what we have seen so far. As a team, we are working on an opportunity. Connected with that opportunity, we have defined an hypothesis. We know where we are going to test. And we also know which metrics we need to monitor. Now, we need to decide whom to test with. So, we need to define our sample. Let's look at all the concepts related to the sample definition in our A/B test canvas. We are in block 5, experiment configuration, and we see that in order to determine our sample, we need to describe the following concepts: power, significance, MDA, and duration. Okay, let's go for it. What is sample? As we have seen, again, what is sample? As we have seen, A/B testing is a type of experiment that allows us to learn what works and what does not work in our product, impacting only a small part of our audience. In this way, we minimize the risk of showing a version of our site or app that our users dislike and give us the possibility to be more daring. This small part of our audience is known in experimentation as sample. But not any portion of our audience is an adequate sample to obtain valid insights for the entire population. Our sample must allow us to apply the learnings we obtain from it to the entire audience. A good sample needs to have the right size and have to represent our audience. Let's see why size is so important when working with samples through an example. Let's imagine that we have a normal coin, heads and tails. We all know that when tossing a coin, we have 50% probability that it will come up heads and 50% probabilities that it will come up tails. Let's also imagine that we do a little experiment to verify that this is true, that our coin meets that proportion. And to do it, we decided that our sample will be the result of flipping the coin 5 times. We do it, and we get 4 heads and a tail. If we stop the experiment here and try to draw conclusions, we will say that our coin have 80% probabilities of come up heads. We will falling into error. Again, let's see why size is so important when working with samples through an example. Let's imagine that we have a normal coin, heads and tails. We all know that when tossing a coin, we have 50% probability that it will come up heads and 50% probability that it will come up tails. Let's also imagine that we do a little experiment to verify that this is true, that our coin meets that proportion. To do it, we decided that our sample will be the result of flipping the coin 5 times. We do it, and we get 4 heads and a tail. If we stop the experiment here and try to draw conclusions, we will say that our coin have 80% probabilities of come up heads. We will falling into error. What's going on? We are in error because we are considering valid a result that is not statistically significant. Let's go through this concept. The example of coins helps us introduce 2 key concepts in experimentation: significance and error. What does significance mean in an experiment? It means that we have evidence that the result that we have seen in the sample also exists in the entire population. This is what allows us to make decisions. Making a decision based on a result that is not statistically significant will drive us Making a decision based on a result that is not statistically significant will drive us to error. There are 2 types of errors. There are 2 main types of errors which we want to avoid. Detect an effect when it really does not exist, and this is known as type 1 error. We must avoid this situation. We don't want to make a change to our product thinking that it improves the previous version when it really is not improving it. Even it can be worse. The second unwanted situation consists of not detecting an effect when it actually exists. The second unwanted situation consists of not detecting an effect when it actually exists. This is known as type 2 error. Again, it is a shame having found a way to improve our product and letting it go. Again, it is a shame having found a way to improve our product and letting it go by not having defined our experiment well. How can we protect ourselves from making these mistakes? Type 1 error is controlled by adjusting the confidence level of the experiment. We should always work with at least 95% confidence. Type 2 error is controlled by defining the power of the experiment, and we should always work with a power of 80%. Let's look at the concept of statistical significance with a little more detail. Let's look at the concept of statistical significance with a little more detail. What error are we assuming based on the level of significance we define? This table helps us answer that question. Suppose that the result of our experiment is significant in 80%. In common life, 80% is quite enough. Even in some situations, it can be a lot. But in product development, it implies that we are going to modify our product thinking that we are improving it when this is not the case 1 out of every 5 times we roll out. For this reason, we must ensure that the results we observe are significant at a minimum of 95%. When we are doing an experiment, we must assume that the error cannot be 100% avoided. It can be reduced. Working with 95% significance, we assume 1 error out of every 20 attempts. Okay, we have to calculate our sample size with 90% confidence level and 80% power to control error. But how big my sample should be? It will depend on how sensitive we want our test to be, and also the conversion rate we want to optimize. Sensitivity and minimum detectable effect. Sensitivity determines how big will be the difference you will be able to detect with your experiment, with statistical significance. Sensitivity in A/B testing is defined by the minimum detectable effect of your experiment. So, what is minimum detectable effect? Minimum detectable effect is an estimation of the smallest improvement we are willing to be able to detect with our experiment. The smaller the minimum detectable defect, the bigger sample we need. Let's go through the minimum detectable effect. How to define a good minimum detectable effect? First of all, use potential business impact to decide on the sensitivity of your experiment. Use the impact estimation that we use to prioritize as a reference to set the minimum detectable effect. If, when prioritizing, we have an expectation about a development, let's use it to start defining our minimum detectable effect. Our recommendation must always be somewhat less than our expectation. Our recommendation is that minimum detectable effect must always be somewhat less than our expectation. Use minimum detectable effect as a guide rather than an exact prediction. The whole concept of experimentation is based on the fact that you don't know what effect a given change. The whole concept of experimentation is based on the fact that you don't know what effect a given change will generate. Instead of trying to pinpoint the minimum detectable effect, use the calculation as a guide to set boundaries on the time you are willing to invest and the value you expect to generate. If traffic is a concern, make a bolder design. You will learn that the bolder the difference between the two versions is, the sooner you will find whether it's a real difference or simple randomness. Our sample size is strongly affected by the conversion rate we want to optimize and the minimum detectable effect we define. Let's look at this relationship in more detail. The graph shows us how sample size varies depending on the minimum detectable effect that we define. Imagine that we have a base conversion rate of 10%. And as we have learned, we want to detect changes with 90%. Imagine that we have a base conversion rate of 10%. And as we have learned, we want to detect changes with 95% significance. As you can see in the graph, the smaller the minimum detectable effect, the bigger the sample should be. Let's summarize what we have learned today. Sample size is important when we do A/B testing. We have also seen that there are two types of errors that we must protect ourselves again. We have also seen that there are two types of errors that we must protect ourselves again. We have also seen that there are two types of errors that we must protect ourselves from: false positives and false negatives. We have introduced the concept of statistical significance as an element to reduce the risk of error. And we have also talked about the minimum detectable effect and the relationship it has with the sensitivity of the test and with the sample size. If you want to know more about the topics we have seen today, in these links you can find more information. Thank you very much, and see you in the next lesson, representativeness.